our polynomials here. So there's a couple of different ways you're going to see this, so different ways to multiply. The first one is just this is a monomial times a monomial, which one term times one term. Okay, so if you see that here, you have one term times one term. What you're going to do here is it's really just one long multiply problem. You have the numbers to multiply, so 2 times 5, which would give you 10, and then add the exponents of the same base. So look at your exponents that have the same base. So you have an x squared and an x cubed, so you're just adding those. So 2 plus 3 gives me 5, so x to the 5th. Then you have a y to the 1st and a y to the 10th, so 1 plus 10 gives me 11. So that's when you have just monomial times monomial, multiply the numbers, add the exponents. Or even, before I get down to this next one, it even could be like a monomial times a binomial, which we distribute. So same thing. So if I had maybe like a 2x cubed times 3x to the 5th minus 4y, I'm doing a monomial times a binomial. I still multiply the numbers, add the exponents. So this would be 2 times 3, which would give me 6. Then I'm adding 3 plus 5 there, which would give me an x to the 8th. And then I have a 2 times negative 4, which would give me a negative 8. And then when I do x cubed times y, I can't really do anything besides just write them next to each other. So that's what I do. The next example we have is a binomial times a binomial. So there's this special acronym for that called FOIL. Does anybody remember what that stands for? Yeah. So first term times first term means the first term of the each binomial. So that would be 5x times x. And I like to draw lines, so I don't do anything more than once. So 5x times x would give you 5, and then x 1 plus 1 would give you x squared. Then outside is going to stand for the two outside terms of the whole thing. So that would be, I'll just change the colors since it's not erasing. So that would be this 5x and then this negative 7 because they're both outside. So 5x times negative 7 would give me a negative 35x. We just tack on the x. And then inside is the two inside terms of the whole thing. So that would be the 2y and the x. So this is your inners. So 2y times x, nothing to multiply, you just write them all next to each other. So I would do plus 2xy. I like to keep it alphabetical order. And then last are the last term of each binomial. So that would be the 2y and the negative 7. So that would be the last one. 2y times negative 7. 2 times negative 7 would give you a negative 14. And then tack on the y. Then after you multiply, you combine like terms. Do we have any like terms here? No, we don't. So then we're done right there. So the next example is the same thing that we just did, except it's presented differently. So this is 2x plus y squared. When you encounter that, you're not distributing this 2. That means this is twice. So that means this is just 2x plus y times 2x plus y. So when it's squared, it's times itself twice. So you write it twice, and then you FOIL. So again, we would do first. So we would do 2x times 2x. Those are your two first. So 2 times 2 would give us a 4. And then x times x, you're just adding 1 plus 1. So that would give you x squared. Then my outers would be 2x and y. And there you're just going to write them next to each other. So that's a plus 2xy. The 2 on the inside, again, y and 2x. So y times 2x, 2xy. And then the last term of each binomial is y and y. So I would do y times y, which would just give me y squared. Notice when I do multiply, I have two lines coming from my first term. So it's basically I'm just distributing the 2x to both terms, and then I'm distributing the y to both terms, if that helps you to check. Now, when I multiply everything out here, do I have any like terms? Yes. My two middle terms are like terms. So when I add them together, I'm just adding the coefficients. So 2 plus 2 gives me 4. So I have 4xy. I'm not adding any exponents because now we're at the addition step. You're only adding the exponents when you're multiplying. Okay, so then bring down the 4x squared and the plus 4xy and the y squared. So there's our answer there. 4x squared plus 4xy plus y squared. Okay, then the last problem here is a little bit of a challenge one. We have a binomial times a trinomial. So you could do this with distribution, drawing your lines, but it makes it kind of messy. So what I like to do is I'm going to split this. So I'm going to split it like that, and I'm going to rewrite it twice. So I'm going to go x times the second term. So x squared plus 2x minus 6. And then I'm going to go positive 3 times the second polynomial here. Then I'm going to do the distribution for both of these, and then I'll combine like terms at the end. And that just helps me keep everything neat. So when I multiply the x times each term, I am going to get, let's see here, x times x squared. I'll add an x there, so that's going to be x cubed. X times 2x will give me a 2x squared. Then x times negative 6, negative 6x. Then I'll distribute the 3. So 3 times x squared will give me a 3x squared. I'm going to write that right here underneath my other x squared. Okay, you don't have to do that, but it's just going to help at the end because I'm lining up my like terms. So then 3 times 2x, 3 times 2 will give me a positive 6x. And then 3 times negative 6 will give me negative 18. And then since I've lined them up, I can just go like this. And then I can add everything. So I have x cubed that comes down. Here I can add the 2 plus 3 will give me a 5 in front of my x squared. These guys, what's that get? Gone, 0, and then minus 18. So there's our answer, x cubed plus 5x squared minus 18.